Let me ask you something. When was the last time you really thought about your legs not just as tools for walking or training, but as the foundation of your independence? Because here's the hard truth: loss of leg strength is one of the first silent indicators of accelerated aging. And by the time most people notice it, it's already started to impact everything: mobility, energy, metabolism, even longevity. Most people assume muscle decline is something that happens in old age, gradual, inevitable, and far off in the future. But that assumption is wrong. The truth is that muscle loss begins much earlier than we think, often as early as our 30s, and the first area to show measurable decline is the lower body. Specifically, the large muscle groups in the legs, quads, glutes, hamstrings are among the first to weaken, even in people who believe they're relatively healthy. The problem is that this decline is silent. It doesn't make headlines in your body. It doesn't hurt. It doesn't interrupt your daily life until one day it does. You might notice it subtly. Getting up from a chair feels a little slower. You hesitate at the bottom of a staircase. You avoid squatting to pick something up from the floor. These moments are brushed off as being tired, distracted, or simply having a lazy day. But they are often the first signs that your neuromuscular system is shifting. And once that process begins, it doesn't reverse on its own. That's what makes early detection and intervention critical. The decline in leg strength is not just about vanity or athleticism, it's about biology. The muscles in our legs represent some of the most metabolically active tissue in the body. They are energy hungry, they regulate glucose, they support posture, they stabilize joints. And they are essential for the mechanical output needed for walking, running, and balance. So when leg muscles begin to atrophy, even slightly, it has a ripple effect across multiple systems: metabolic health, cardiovascular output, insulin regulation, joint integrity, and even cognitive function. Research from multiple longitudinal studies, including those on sarcopenia and frailty, shows that lower body strength is one of the strongest predictors of mortality. It's more predictive than BMI. It's more predictive than cholesterol levels. In fact, people with greater leg strength in midlife tend to live longer, have fewer hospitalizations, and recover more effectively from injury or surgery. That's not an accident. It's physiology doing what it does best, prioritizing what keeps us upright, mobile, and engaged with the physical world. Now, this decline doesn't just affect the elderly. Even people in their 40s and 50s, especially those with sedentary jobs or minimal physical activity, can show early signs of neuromuscular disconnect. The nervous system starts to lose efficiency in recruiting motor units. The brain becomes less precise in sending signals to the muscles. The feedback loop weakens, and as a result, power output suffers. You may still have the muscle mass, but the ability to recruit it on demand, especially under stress, diminishes. That's where performance starts to drop and injury risk rises. What makes this so challenging is how normalized it has become. We live in a world where sitting dominates most of our waking hours. We sit to work, to drive, to eat, to relax. That chronic sitting leads to gluteal amnesia, a term coined to describe the way our brain essentially forgets how to activate certain muscle groups that are meant to stabilize and propel us. When those muscles go quiet, others try to compensate. Knee pain, hip tightness, and lower back issues often follow, not because of an isolated injury, but because of cumulative underuse and poor activation. The body is adaptable, but that adaptability works both ways. Just as we can train it to become stronger and more resilient, we can also train it to become weaker if we ignore the signals. The absence of a challenge leads to the absence of capacity. And for the legs, those massive levers that carry us through life, that absence becomes one of the greatest threats to long-term health and functional independence. The good news is that the body also has a remarkable ability to respond when given the right inputs. But before that happens, we have to shift the way we think about leg strength. It's not just something for athletes or the young. It's not just for aesthetics or performance. It's foundational to longevity, and like all foundations, when you ignore the early signs of wear and tear, the collapse comes faster than expected. Most people don't fall because of a single event. They fall because the foundation has been eroding for years. And that erosion starts with the gradual, almost imperceptible weakening of the legs. When most people think about leg strength, they associate it with movement: walking, running, climbing stairs. While that's true on the surface, the implications of leg strength go far deeper than mobility alone. In fact, the strength of your lower body has been shown to have profound predictive value across multiple domains of health, including metabolic regulation, cognitive performance, and overall mortality risk. This isn't just about being able to squat more weight or run a faster mile. This is about understanding that your legs are not just muscles, they're central command stations for health. Take insulin sensitivity, for example. Skeletal muscle is the primary site for glucose disposal. That means when you consume carbohydrates, the majority of that glucose is meant to be absorbed by your muscles. The more muscle mass you have, particularly in the legs, which account for a large proportion of total body muscle, the greater your capacity to clear glucose from the bloodstream efficiently. This isn't theory, it's physiology. People with greater leg strength and lean muscle tissue typically show better insulin sensitivity, more stable blood sugar levels, and lower rates of type 2 diabetes. It's not the only factor, but it's a massive one, and it often goes overlooked in mainstream conversations about metabolic health. Then there's brain function. Studies have increasingly demonstrated a correlation between lower body strength and cognitive resilience, especially in aging populations. One longitudinal study followed individuals over a decade and found that those with stronger leg muscles at midlife performed significantly better on memory and processing speed tests in later years. The mechanism is still being investigated, but part of it involves blood flow. Stronger leg muscles help improve cardiovascular efficiency, which improves cerebral perfusion, the flow of oxygenated blood to the brain. The more you move, the more your cardiovascular system adapts and the better your brain gets at staying sharp. But the foundation of that movement again starts with leg strength. There's also a hormonal component to this relationship. Resistance training, especially when it targets large muscle groups like those in the legs, stimulates the release of growth hormone, testosterone, and other anabolic signals that support muscle repair, fat oxidation, and even mood regulation. When you activate your legs intensely, you send a powerful message to your endocrine system: adapt or fall behind. And that adaptation is systemic. It's not just your quads and hamstrings that benefit, it's your entire physiology. Leg strength has been associated with higher levels of brain-derived neurotrophic factor BNF, a key protein involved in neuroplasticity and cognitive function. From a biomechanical perspective, leg strength also serves as your body's foundation for movement integrity. Every step, jump, or change of direction is initiated and stabilized through the legs. When that foundation is weak, compensation begins to occur elsewhere in the hips, the spine, the knees. That leads to pain, dysfunction, and a cascading effect of reduced physical activity. Over time, that reduction becomes a feedback loop. Weaker legs lead to less movement, which leads to even weaker legs, and the cycle continues. And then there's the psychological component. There's a unique confidence that comes with strong legs, a kind of groundedness, both literal and metaphorical. People who feel stable in their lower body are more likely to engage in physical activity, more likely to take risks, and more likely to maintain independence as they age. That sense of stability is not just physical, it's deeply tied to identity and autonomy. When people lose leg strength, they don't just lose physical capability, they begin to lose the freedom to engage with the world on their own terms. It's important to understand that these benefits aren't reserved for elite athletes or people who spend hours in the gym. The body doesn't require perfection, it requires signals to grow, to adapt, to hold on to function instead of letting it wither away. Even small increases in leg strength measured in grip strength, sit-to-stand capacity, or stair climbing ability are associated with measurable improvements in health outcomes. You don't need to become a power lifter to change your trajectory. You just need to move with intention, to eat in a way that supports growth, and to prioritize the lower body as the engine room of your future. Most people think health is about isolated variables: heart rate, cholesterol, blood sugar, but leg strength touches all of them. It's a keystone metric, a predictor, and a lever you can pull that moves multiple systems in the right direction at once. When we talk about nutrition, we often focus on calories, macros, or even vitamins and minerals, but what's rarely emphasized is how specific nutritional interventions can influence neuromuscular health on a rapid timescale. The relationship between what we eat and how our muscles perform is not just a matter of long-term training and gradual results. It can actually begin to shift within hours of ingestion. This is especially true when the food consumed has a precise amino acid profile that directly supports muscle protein synthesis and neuromuscular coordination. When the right fuel enters the system, it doesn't just nourish, it communicates. It signals. And the muscles listen. Every movement we make is the result of complex interactions between the brain, the nervous system, and the muscular system. For that relationship to function optimally, the body needs a steady supply of amino acids, particularly essential ones, that cannot be produced internally. These are the building blocks the body uses not only to repair muscle tissue but also to maintain neuromuscular junctions, reinforce mitochondrial health, and optimize neurotransmitter balance. A single meal rich in these key nutrients can begin this process by supplying the substrates needed for the body to shift from breakdown to repair, from maintenance to growth. The neuromuscular system is in a constant state of flux. It's not static. The body is either in an anabolic state, building and strengthening, or in a catabolic state, breaking down tissues to meet energy demands. What most people don't realize is that specific foods, especially those rich in leucine, isoleucine, valine, and other branched-chain amino acids, can tip the balance toward the anabolic state within a very short window. This shift isn't theoretical. It's measurable. Muscle biopsies taken within hours of consuming high-quality protein sources show increased markers of protein synthesis. Electromyography data indicates improved muscle firing patterns. Neuromuscular efficiency can improve not just from training but from feeding. This is particularly important when we're talking about recovering leg strength or reactivating dormant muscle fibers after periods of disuse. The nervous system's ability to recruit muscle fibers is dependent not only on practice in mechanical loading but also on the internal biochemical environment. If the right precursors aren't available, the nervous system doesn't fire as efficiently, and the muscle doesn't respond as quickly. But when the right nutrients are present, when the body has the raw materials it needs to build and repair, everything works better. Reaction times improve. Coordination increases. Strength can return faster than expected, not because of magic, but because the physiology is finally supported at the cellular level. Consider the role of neurotransmitters like acetylcholine, which plays a key role in muscle contraction. The production of acetylcholine depends on nutrients like choline, B vitamins, and certain amino acids. Without them, the signal from the brain to the muscle becomes weaker. But with the right input, that signal is restored, strengthened, amplified. That's not just an abstract process, it translates into better balance, faster reflexes, and more confident movement. And it can happen quickly, because the body is wired for adaptation when conditions are right. There's also a hormonal cascade that begins once high-quality protein is consumed, particularly when it's paired with specific micronutrients. Insulin, for example, is not just a blood sugar regulator, it's a powerful anabolic hormone that facilitates nutrient uptake into muscle tissue. When insulin is elevated in response to a nutrient-dense meal, amino acids are transported more efficiently into cells, and the machinery of growth is activated. When this process is targeted, when it's not just random but intentional, the impact on muscular function can be surprisingly fast. This is why some people can feel a noticeable difference in strength and energy within hours of correcting a nutritional deficiency or consuming a therapeutic food. One of the most overlooked aspects of muscle recovery and performance is mitochondrial function. The mitochondria inside our muscle cells are responsible for producing the energy needed to power contractions. If they are underfueled or dysfunctional, strength output drops, but certain nutrients like creatine, carnitine, and coenzyme Q can rapidly enhance mitochondrial efficiency. When present in the right food, these compounds help the muscle generate more force with less fatigue, even after a single meal. That's why nutrition can feel like a performance-enhancing switch. You don't always need weeks to see change. Sometimes you just need the right input at the right time. When it comes to regaining leg strength, particularly after periods of inactivity or weakness, relying solely on exercise without considering nutritional support is like trying to build a house with no materials. The stimulus alone isn't enough. You need the bricks, you need the scaffolding, you need the instructions, and those come from food, not just any food, but food that's rich in the amino acids, micronutrients, and cofactors the body uses to repair, rebuild, and reactivate muscle tissue quickly and efficiently. There's a specific signaling pathway in the body that acts like a master switch for muscle growth, repair, and protein synthesis. That pathway is known as mTOR, the mechanistic target of rapamycin, and it's one of the most critical regulators of how the body builds and maintains lean muscle mass. When mTOR is activated, it tells the body to shift into an anabolic state. It tells muscle cells to start producing new proteins. It enhances nutrient uptake, stimulates growth, and helps rebuild strength that may have been lost due to inactivity, illness, or aging. And what activates mTOR most potently is not a supplement, not a drug, and not a workout. It's a very specific combination of nutrients found in food. Among the many nutrients the body needs, there's one amino acid that stands out when it comes to activating mTOR: leucine. Leucine acts almost like a trigger. It binds to receptors that stimulate mTOR and send a powerful message throughout the body: it's time to build. It's time to grow. It's time to restore function. This is why certain foods, especially those rich in leucine, have the ability to activate mTOR within hours of being consumed. The effect is rapid, direct, and measurable. When the body receives the right signal, it begins to shift internal priorities toward repair and regeneration, particularly in skeletal muscle. Muscle protein synthesis is not just about adding size or strength, it's about maintaining function and resilience, especially in the lower body where large muscle groups like the quadriceps and gluteus maximus are responsible for posture, locomotion, and joint protection. When these muscles begin to atrophy, the body loses its ability to stabilize itself. Gait changes, balance becomes compromised, and injury risk increases. Activating mTOR through targeted nutrition is one of the fastest ways to interrupt that cycle. Instead of continuing to lose strength day by day, the body starts reclaiming it, one signal at a time. But this activation isn't just about protein quantity, it's also about protein quality. Not all protein sources are equally effective at stimulating mTOR. Some foods contain incomplete amino acid profiles, or they lack the leucine threshold needed to trigger a full anabolic response. The foods that activate mTOR most effectively are those that contain complete proteins with a high biological value. These are foods that the body can digest and utilize quickly, efficiently, and with minimal waste. When these foods are consumed at the right dose, typically containing at least 2 to 3 grams of leucine per serving, they can begin to stimulate muscle protein synthesis in a matter of hours. This is not just a theoretical framework. Studies using muscle biopsies and tracer methods have confirmed that consuming a leucine-rich meal can stimulate mTOR activity in muscle protein synthesis within as little as 60 to 90 minutes. In practical terms, this means that even a single targeted meal can begin reversing muscle loss that may have taken weeks or months to occur. It won't complete the job alone, but it initiates the process. It turns the tide. It sends the signal that muscle is valuable, necessary, and worth maintaining. What's remarkable is how sensitive the body is to these inputs, especially after periods of inactivity. When muscles haven't been stimulated either through exercise or nutrition, they become more responsive to anabolic signals. This is known as the muscle-full effect, where underutilized muscles absorb amino acids more aggressively during refeeding phases. When the right food is introduced at this moment, the response can be amplified. The mTOR pathway becomes hyper-responsive, leading to accelerated gains in strength and functional output over a short period of time. Another layer to this process involves satellite cells, specialized muscle stem cells that help repair and regenerate muscle tissue. The activation of mTOR not only increases protein synthesis in existing muscle fibers, but also encourages these satellite cells to multiply and fuse with damaged fibers, making them stronger and more capable of handling future stress. This is how real, lasting recovery begins, not just by maintaining current tissue, but by laying the groundwork for new tissue to form. The downstream effects of activating mTOR don't stop at the muscles. They influence the immune system, glucose metabolism, and even the brain. A strong, responsive musculoskeletal system supports systemic resilience. It supports metabolic flexibility. It supports neuroprotection. And all of that can begin with something as simple as a meal if it contains the right nutrients in the right ratios at the right time. Most people underestimate the power of food to act as medicine, especially when it comes to regaining physical capacity. But the science is clear. When you eat the food that activates mTOR, you're not just feeding your body, you're programming it to rebuild, regenerate, and regain lost strength faster than you thought possible. When we think about improving strength or reversing muscle loss, the default strategy that comes to mind is usually exercise resistance training, physical therapy, or some form of movement protocol. While exercise is undeniably important, there's a critical but often overlooked factor that can produce measurable improvements in muscular function, even in the absence of training nutrition. In fact, certain short-term dietary interventions can create significant shifts in strength, stability, and recovery without lifting a single weight. This is especially powerful for individuals who are injured, fatigued, recovering from illness, or simply unable to engage in traditional training due to age, joint issues, or time constraints. Muscle is a dynamic tissue. It doesn't just respond to mechanical stress, it also responds to biochemical inputs. The foods we eat directly influence cellular hydration, enzyme activity, mitochondrial output, and most importantly, the muscle protein synthesis pathway. When the body receives a precise combination of amino acids, electrolytes, cofactors, and energy substrates, it can begin to repair and even grow tissue under conditions where exercise isn't present. This is not just useful, it's essential, because there are times when movement is limited and the only available tool is the one on your plate. Take, for example, individuals recovering from surgery or managing chronic conditions. In these cases, the risk of muscle atrophy is extremely high. The body defaults to a catabolic state to preserve energy, and without intervention, strength rapidly declines. But studies have shown that targeted nutritional protocols, especially those high in essential amino acids, omega-3 fatty anti-inflammatory compounds, can attenuate or even reverse this process. Within hours of consumption, the body begins to shift from catabolic to anabolic, from breakdown to repair. Nitrogen balance improves, muscle tissue retains more protein, and the inflammatory response that often inhibits muscle regeneration is modulated in a favorable direction. Even in healthy individuals, consuming the right nutrients at the right time can lead to noticeable changes in performance, energy, and strength. For example, a single high-leucine protein meal paired with electrolytes and fast-digesting carbohydrates can rapidly replenish glycogen stores, improve muscle firing, and increase work output on subsequent movement tasks. This effect is not theoretical, it's observed in real time using strength testing, EMG analysis, and performance monitoring. What the data shows is clear. The body is highly sensitive to nutrient availability, and it responds with remarkable speed when the right compounds are present. This response is even more pronounced when addressing deficiencies. Suboptimal intake of magnesium, vitamin D, potassium, and B vitamins can all negatively impact muscle function, coordination, and energy metabolism. Correcting these deficiencies, sometimes even through a single well-designed meal, can lead to dramatic improvements in how the body feels and functions. There are documented cases where individuals who struggled with leg cramps, balance issues, or fatigue experienced resolution of symptoms within a short window after addressing micronutrient gaps. This highlights how tightly muscle function is linked not just to training stimulus but to cellular nutrition. In athletes and performance populations, this principle is used constantly. Nutritional timing and composition are optimized down to the hour, and sometimes the minute, to enhance output and accelerate recovery. But these same strategies work for everyday people, two people trying to walk without assistance, climb stairs, or regain confidence in their lower body. When the food consumed is designed to meet the needs of recovery and repair, the gains aren't just possible, they're often faster than expected. Especially when inflammation is reduced, insulin sensitivity is improved, and the neuromuscular system becomes more efficient at recruiting motor units. One of the most powerful effects of a targeted nutritional intervention is the reactivation of dormant or underused muscle fibers. These are fibers that haven't been firing efficiently due to disuse, aging, or injury. With the right fuel, these fibers can regain conductivity and contribute again to strength production. That process doesn't require weeks of training to initiate. It simply requires the restoration of metabolic capacity and the presence of the biochemical tools needed for activation. In many cases, people don't realize how much strength they still have simply because it's been masked by undernourishment at the cellular level. Even the act of improving hydration status through electrolyte-rich foods can lead to increased muscle performance. Sodium, potassium, calcium, and magnesium all play roles in muscle contraction and nerve transmission. When these minerals are imbalanced, strength suffers, but rebalancing them even in the short term can lead